We personally only use DOM in all of our aftermarket cages. We do offer chromoly, but that is going to be more geared towards the race car industry. I too have seen stuff on social media where guys are building cages out of ERW instead of DOM. I know it's a cost savings, but there's reasons we don't want to use ERW for cage building. ERW is heat, well, it's a heat friction. So this tube through the extrusion process is going to reach temps well over 2,000 degrees. What that does is it changes this material, the structure of the material, and makes it more brittle. And you can see here, we have what we call snake skinning, which is where the material wrinkles because there's no elasticity. And it also flattens out on the back side of our bend. So both this material, this is 120 wall, 1 3/4 ERW. This is 120 wall, 1 3/4 DOM. So again, like I said, it becomes more brittle, doesn't have elasticity to it. It actually causes a fatigue point in the bends. Whereas if you go to our DOM, you can see this is cold drawn. So the tolerances are tighter, the material keeps its elasticity. And you can see inside, we don't have any of that wrinkle that we have here. We have a well-formed bend, keeps the radius. Personally, our bends stay within 3% of deflection versus this is well over probably 10% deflection on the ERW. And that's why we built all of our cages out of DOM only. I'm not going to take away from ERW being a good structure piece for bumpers, rock sliders. This is the material we use for our bumpers, our rock sliders, any of our accessories, tire racks, so on and so forth. But as far as something that is going to be involved with a person's safety, we absolutely will not use this material. Here's a prime example of what happens. So this is ERW. This is 120 wall ERW. You can see the bend failure right here, and where the material actually imploded on itself and pulled in the back. And this is why we absolutely will not use it. As far as factory goes, I've seen the same questions. What's the difference between factory and aftermarket? Aftermarket, us personally as a manufacturer, we only follow, or we make sure we follow SCORE, BITD, which is best in the West. We follow those race sanctions because if you get on their website, and I strongly encourage anybody buying a cage or building a cage to get on these guys and get on these sanctioning websites, follow through SCORE, BITD. They all have multiple page reasoning and real explicit, real in-depth reasons why they sanction the cages. They have weight ratings, tube size, weld points. If you're going to tackle a cage, you need to make sure you understand the basics if you're going to build your own. And if you're buying a cage, you want to make sure that you look over weld quality because it is listed. So we follow, here's two examples. This is SCORE and this is BITD. And you'll see there's 20 pages here, and half of it alone is just on material usage, cage design, so on and so forth. As a manufacturer, our personal belief is our materials, our products, our accessories are by far superior to factory for these reasons. As you can see here, factory cages are bolt together, light wall tubing. They are seamless, but they are light wall. This is designed, engineered for the intent of one-time rollover. It is there to protect you as the machine goes over. Our cages are designed to be able to handle multiple rollovers. With that said, you need to have, if you're in a major accident, if you rolled the machine over multiple times, it would be good to send the cage back to us, or see if whoever you bought your cage from will inspect it before you just put it on another machine, or take it and repair it. We do inspect all of our cages. If you do get in an incident where you have rolled one over multiple times and the machine is in major damage, please feel free to send us back the cage. We'll strip it down, re-x-ray all the welds, re-stamp the cage, and send it back to you. I personally don't like the idea of cutting down a factory cage for various reasons, like we talked about just a minute ago. Light wall seamless tubing, they have cast pieces involved. So with cast, it has to be preheated and has to sustain a heat, a certain tolerance, while the welding process is being done. So we have already inherently put, from the factory, have put a ton of heat deformity, I guess, would be the best I can think of, into this cage. So if we're going to cut it, now we're going to push more heat deformity up through the material. When I'm talking about deformity, I'm talking about like the ERW when I was explaining how the heat makes it more brittle. We are expanding where the range of brittleness is. So now we're causing this to be more of a splinterable material now, instead of having elasticity that it would have. Another thing is, if you guys are cutting a cage, so if you look at a cage design and factory versus aftermarket, we all have to kind of adhere to the same reasoning. You need pressure pass points. So if you take a roll and you land on that side, you need that pressure to be able to travel fully across and dissipate back into the chassis at a safe point. So if you come in here and you cut this cage in the middle, you shorten this piece up and bring it down. Now you're taking that pressure point, that release point, and moving it from the chassis up to your weld point. The strongest piece that's going to unfortunately be here is the piece that you slip inside. That's, to me, I don't like that idea. I want to talk about pressure release. So something you guys need to think about, whether you're buying from us or any manufacturer. You want to make sure, or if you're building yourself, you want to make sure that the cage design allows pressure to be dissipated at any juncture. So what I'm talking about is, you have a cage, you go from A to B pillar with a mono tube, and then we have our joint pillars, crossbars, sub crossbars. We want to make sure all these points come to a definitive area. We don't want to have this crossbar come up and this dissipation point be moved, because now we've taken it from pressure dissipation. If we land on this side, it allows this pressure to travel from here across the tube, across the cage, and dissipate on that side, keeping the structure. This bar is moved forward. This now is a shear, because now we have induced a fault. So anytime you're looking at a cage to buy it, you want to check the integrity. Same with you guys. We have twin bars that we run, that we design. They take pressure from the front of the cage, dissipate it back through, so unilateral. So if you were to take this in an endo and you were to say you're coming over a dune and you landed face first, we're now going to take all that pressure from the machine, brings it into this corner, which is now going to allow pressure to come through multiple tubes, thus holding its structure. Because these tubes are tied together via gussets or double crossbars, so on and so forth. That's things that you really want to look at. Material-wise, where you land the cage, the bung area, we only use, that's why we use only forged parts, limb tubing. So we take the fatigue point out of the cage and move it to the machine. Factory cages, back to your question about factory versus aftermarket, why we don't want to cut it. These are cast parts. These are probably the sand cast part. They're not going to take out the fatigue. These can shear, whereas our forged parts won't. Hope you guys enjoyed this Tech Tuesday video. We're planning on doing more of them. Make sure you subscribe and like our channel. If you guys see anything or would like us to do a review, drop it in the comments below. Hope we give you guys enough information. If you see anything else you'd like information on, please comment, contact us. If you are looking in the market to buy a cage or you're building your own cage, feel free, whether it's from us or anybody else, please contact our support at support@nitromountain.com. We'd be happy to answer any questions, any concerns you may have. You can pick our brain anytime.